So why do we do the depth first traversal algorithm? What are its examples and real life applications that I can think of? So basically the depth first traversal algorithm has many utilities in almost a lot of algorithms, graph algorithms that are used. For example, let's look at this topological sorting. Now topological sorting is basically a linear ordering of directed graphs vertices in such a way that for every directed edge uv from vertex u to vertex v, u comes before v in the ordering, right? So for example, we can use this to establish a particular ordering where if I want to complete one task and if it has some dependencies like say task B, task C, and task D, have some dependencies on task are the dependencies of task A, I cannot complete task A until I have completed all these other dependencies. So a good example would be here to cook a dish of pasta, for example. So I need to first preheat my oven to bake my bread, and I also need to bake my bread. So that is the condition that happens before the baking the bread. Then for boiling the pasta, I need to first set the table. First boil the water and add pasta to the water, and then after that I will follow it up by serving the pasta. But serving pasta also requires me to set the table, right? So I will have to set the table before I either serve pasta or serve the bread. So these are the dependencies for serving bread. This would be the dependency for serving bread, which is setting the table. Next, if I want to have a nice sauce over my pasta, so I cannot do that until and unless I have served my pasta on a plate and I can drip the sauce over it. So next I will heat up the sauce and pour the sauce over my pasta, and finally I can eat it. So a topological sorting will establish a particular set of tasks that I need to do it in a particular order in order to attain an end goal, right? Now let's look at another example. So this is again another good example of topological sorting, where I need to buy ingredients to bake something. For example, I want to make lasagna in this example. So I need to buy the ingredients and fry the sausages, make sauce. At the same time, concurrently, I can also boil pasta and grate cheese. And then after all these tasks have been completed, I can assemble my lasagna, which will be followed by baking the lasagna. So this is again a good example of topological sorting. Now the idea behind explaining you topological sorting is topological sorting uses the depth first search algorithm to establish this particular order, right? To establish the order in which the tasks have been completed. So the depth first algorithm is the main backbone of a topological sorting. Another example that I can think of is connected components. Now connected components in a graph are all the nodes that have that are reachable by an edge, right? So for example, in this graph example, we have nodes 0, 1, 2, 3, 4, 5 as part of one connected component, because there is some edge linking one node to the other. They're connected somehow, and 6 and 7 is another component. So in this super graph, we have two subgraphs which are connected components by themselves, right? Now DFS algorithm can also be used to find out these connected components, as we saw in the worked out example that we worked out in a few minutes ago. We saw that some nodes are not reachable, so we can find out the connected components of a graph using the depth first search traversal algorithm.